What's up, my dude? Well, it's been a minute. Yeah, I know that I'm kinda vanished for more than a year. Of course, if you don't take into account that video that I posted back in August. And even based on that, you can definitely tell I was not in the right headspace for creative work or YouTube in general. The burnout was pretty much real. And the good thing about burnout that after each of those, there is always light in the end of the tunnel. And yeah, so I'm trying to say that I'm definitely better now and actually excited. You can count that as a official channel reboot, bringing that from the dead, I would say. So if you've been waiting for proper technical vlogs, they're so coming back and stronger than ever. Yeah. And you know what the most authentic attribute of these vlogs? Yeah, a nice cup of fresh coffee. So let's get it. Much better. So a lot of things have happened. Kaya and I moved to another neighborhood here in Montreal. I think it's already fourth time since we arrived in Canada. So basically once a year, and some life priorities have shifted. I'm not that actively looking for a new job, but I'm always open to new opportunities. I'm happy with my current employer, and most importantly that I want to build again. I want to build new feature that would bring me joy. I want to share the entire process on this channel. I know that I was guilty of starting things on this channel and not finishing them. That might be funny, but I really believe that this time would be definitely different. And that's what I meant by exciting, because building new projects is always something that I loved. I love to build complex mechanisms, stitching everything together and see how everything works properly and flawlessly. So yeah, that's a main idea. And after that project, I think go the next one and the next project and the project after that. So that's probably the main course would be for this channel for now. And you can ask, what kind of project are you trying to build right now? And I'm gonna tell you. This is basically super simple idea. It's a URL shortener, and fair enough, you can say it's kind of trivial project, but the outcome that I pursue here is I need a service that would serve me. I need super simple design and yet modern and beautiful looking. I want to not over-engineer stuff because I set some constraints for me. I just want to ship something to the world so others could also use that, and I want to build it really from the ground up without any templates, any boilerplate codes whatsoever. Also, you can wonder why I cannot use other shortening URL services, and I tried a lot of those, to be honest, and I found those services kind of overwhelming in a way. So there are a lot of features that I don't use and they are so distracting. I just wanted to keep it simple, you know? I need a simple shortening function, I need a simple analytics, and basically that's it. Simple as that. So yeah. And now let's draw some boxes. Yo. So the system design is super simple. The application is web-based, so obviously user needs to use the web browser. The first component that meet the request is gonna be verse proxy, and I'm gonna explain a bit later why do I need that. But TLDR, it's basically to routing the right request based on the URL path, either to front or to backend. So here I have a front end, which would be Next.js application, and I'm gonna use only front end logic, no server actions whatsoever. And for server logic, I'm gonna use Spring Boot with the Java 25. So we're gonna use the latest and greatest here, and the backend should be communicated with the SQL database. Here I want to talk a bit more about the backend. So in order to like protect my service from the basic abuse, I'm gonna use rate limiter, and the configuration of that would be different for different endpoints. For instance, here for writes it should be lower, for reads it would be higher. So here we have URL shortener component, then goes URL redirect, then URL analytics, and URL analytics talks to geolocation. Essentially, I need this to determine the country of the redirect request. And in case of the redirect and analytics services, they talk to SQL database, and in some instances it can be really high RPS. So to optimize read operations, I've put in-memory cache here, and the same applies for geolocation, but in case of geolocation it talks to geolocation file. Essentially, I'm gonna load this file on the application startup, and from that point I'm gonna talk to in-memory cache only. Alright, so one of the questions you could ask is, why don't I use Redis instead of in-memory cache? In my case, in-memory cache would work fine because I do not need like shared data across multiple instances. So every instance basically would have its own cache layer, and yeah, that's basically fine for this kind of version of the application. And in the future, if I would need Redis, I'm gonna add it, but for now I want to keep it super simple. I do not want to add unnecessary dependencies. I already have like SQL database, and that should be enough. As for the IP geolocation database, it's going to be stored within the backend, so that's also fine. Alright, so let's get back to reverse proxy, and I'm gonna explain how would I use that. So when I were researching different redirection strategies for similar URL shortener services, I realized that some of the services use one domain name for their front-end application and another domain for redirection path. But I don't really want to use another domain name or whatever. I want to use the same one. Okay, I'm gonna call it for now myshorturl.com. And basically what I mean by that is some of the services put like, let's say, redirect, and then goes your short URL. But I don't really want to put anything here. I don't want to use another domain name. I want to use the same one. And this is obviously not my domain name. I'm gonna use a different one. But anyways, how do I resolve that? So yeah, when I have my domain name, I need to somehow determine the strategy for redirecting the request to the either front end or the backend. So essentially I have a route path for landing page, then I would go logging and registration pages. These should go to the front end. These two should be also forwarded to the Next.js application, and then I would have /API, and all the requests here should go to the backend. Alright, so something like that. And how do I resolve that if I don't want to have different domain name? So what I found out, basically I can say like R, that stands for redirect, and every pattern that matches that would also go to the backend. And that means that our short URL from this should be changed to this pattern. It's not super like pretty or ideal, I would say, but it's fine for me. Honestly, it's fine. Yeah. So I'm gonna add another configuration in Nginx, and that would forward all the /r requests to my backend. Simple as that. So now let's try to think how we could actually shorten URL. We could apply hashing algorithm that can be MD5 or SHA or something like that. So let's say we have two long URLs which were created by different users, and in case of the hashing functions, we would basically have the same hash value and our short URL collide with the previous one. And we don't want that. So another way that we could go with can be the counter that can be increased list with every URL shortening. So we could start from 1, then 2, 3, 4, 5, and so on. And each counter value we could encode with the base 64 algorithm that would give us alphanumeric value. However, for this solution, we would require a centralized counter, and to achieve that, we could use Redis. But as I mentioned before, I don't really want to use Redis because it's over-engineering in my case. It's extra dependency. Additionally, if someone would decode the short URL, they would guess that it's counter-based, and that's not super great for application security. And this brings us to the last third solution, which is gonna be basically random short URL. So in this case, you could argue that if we randomly generate short URLs, at some point they would collide. However, if we generate our short URL value based on the alphanumeric characters, and let's say we give it 6 characters length, that would give us 56 billion possible combinations. That sounds like a lot, but there is basically a chance that in some random generations our short URL would collide and we won't be able to store it in database. But it's still not the end of the world, because we always can retry and try to generate value again, and if that succeeded, we successfully stored that in database. But after some time we could notice that there are a lot of retries, and that's not great for user experience because the latency would increase, and let's say the one URL could take up to 100 milliseconds and the next URL would take up to 1 minute. I bet some users would be angry and won't want to use the service anymore because it's extremely slow. Luckily, the resolution of that is super simple. We just increase characters number for our short URL from 6 characters to 7. That's gonna be around 3.5 trillion combinations. But if our service will become super popular and even that number would cause us some issues, we basically changed that to 8 characters and the combination number will go up to 218 trillion combinations. So at this point, I don't really think that this number would cause any issues, especially if we have our rate limiter and users cannot instantly generate thousands and thousands URLs per second. So this solution is more than fine. And this is pretty much it. I just need to implement every single component. That's where the fun begins. Today is December 5th and it's extremely cold outside. It actually was the first coldest night here in Montreal so far. The temperature dropped to minus 17 degrees Celsius, but I know Canada can do way better than that. Anyways, I'm happy I don't need to go outside often. So I'm gonna enjoy my lemon tea and tell you what I managed to do so far. Alright, here I came up with a short to-do list on items that I needed to implement this week. So basically I need to generate a Spring Boot 4 project with Java 25, add multiple dependencies. Also, I needed to create a Docker Compose file to spin up my Postgres instance. And then I wanted to create the bare bones features, like the actual implementation of the URL shortening. I wanted to store all the important information in property files. Of course, I needed to have a controller to handle requests, have auditable entities. I'm gonna explain later what does it mean. And of course, everything that is created should be stored in database, and then there should be an endpoint in my application that would allow to redirect all the requests that came with the shortening URL key. And the last point is to add a cache layer to my redirect controller. This one I didn't manage to finish, so I'm gonna put that in the next week. Here we go. So yeah, now let's go step by step and I'm gonna explain everything. First of all, I have my main entity for short links that contains a lot of information, but for now we're gonna focus on auditable entity, and this is basically an abstract class that contains version, and it extends another abstract class that has created timestamp and last updated timestamp. So why do I need those classes, and why should my entity extend this class? So these two fields are self-explanatory. Created timestamp is a field that automatically sets current date time on the entity creation when it's initially saved in database, and this one is updated on each entity update, and everything is done automatically, so you don't need to do anything to maintain that. The second entity is more interesting. It's a version, and basically it's used for optimistic locking for our database entity. And what I mean by optimistic locking, it's a strategy that allows to handle concurrent updates to the same database record. So this version field is increased on every database update, and imagine situation where two users try to process the same entity simultaneously, and before they save entity in database, they should need to fetch that, and they have the same version. The first user saved the entity in database and the version increased at that point, and then the second one tries to save the same entity, but the version is older than the current set in database, and at that point the second user will fail. So to simply put, it's a mechanism that allows to prevent to save outdated data. Alright, so let's get back to our entity. For now I want to keep it super simple. I have a field for storing long URLs, the one that we'll be using for redirection down the line. Then we have short URL key. It's basically a randomized value that you usually see on the services like Bitly and others, and a transient field. We don't care about that for now. What's nice about having dependencies like data GPA and Hibernate is that I can specify the length of my column. I can put some constraints like unique, and Hibernate will do all the heavy lifting, and even that I already have my database and tables created, I can simply remove that. So I'm dropping the table, I can restart the application, and Spring and Hibernate will do all the work for me. So if I refresh here, and I have constraints, indexes created, and also all the columns with the definition that I specified in here in code. So this is always nice to have. And for those who doesn't know, Hibernate is the most powerful ORM in Java ecosystem. And you can actually ask why I choose 2048 characters length for my long URL. And I have explanation for that. So I did my research, and apparently some of the browsers have a lower number of characters that they allow for URLs, someone higher. So for instance, Safari supports 80k characters, but I'm honestly happy that the lowest number is not that big, because otherwise my database would explode on the high load. So to be able to support all the browsers, we're gonna pick the lowest number in this table. And here is my main controller that has a redirection endpoint and the one for short URL creation. And again, Spring provides super easy way to redirect requests to any URL that you want, and to preserve all the query parameters that original URL has. And now let's test how everything works all together. So as I mentioned before, I needed to create a Docker Compose to spin up my Postgres instance, and I'm gonna try to create a short URL with the query parameters. For instance, I'm gonna create short URL for Spring Initializer, and if I choose multiple dependencies that I want to be there when I go to the link each time, and there is share URL option here. If we check that, we have super long URL with a bunch of query parameters, and we want to have all of those. So even if I remove everything and I want to go to this URL once again, I have all the dependencies already preset. So now let's use Postman to create the actual short URL in our application. So I'm gonna paste the long URL, and here you go. Let's try it out in our browser. and it worked right off the bat. So let's check what do I have in database. Here we have our UID identifier, the long URL, which is the original one, short URL key, and those two timestamps that I explained before, along with the version number. And that's about it for this week. As I mentioned, there is one item that I moved to the next week, and I have a bunch of others. For instance, I need to add rate limitation. I want to have a basic front-end application, and there I want to have a way to create short URLs, update those, delete, get all the created URLs on the separate page, and that would mean I need to have a full CRUD operations for my short links endpoint. Also, I want to have title field. There should be a way to manually set it up, or it should be auto-generated based on the title tag of the long URL. And the last but not least is to add database migration. This is really important, especially for production environments, but this one I'm gonna explain then next time.